everyone, and this is the Chipmaster. Alright, many of you are supposed to be wondering where is Chipmaster. Alright, since I haven't uploaded any videos over here. Alright, this is due to my video editor who has been busy over the past year and stuff, so he had troubles sometime getting the videos to be edited. Alright, my online training videos will be launched as soon as possible. I have over 70 videos, and it's a complete timing sequence of some boards, like for the HP ProBook 4530S, right, and the complete time for the Intel Series 6 chipset. I have the complete timing for the Intel Series 5, which is on the HPDB4, right, PCH, big speak, right, and I've completed that one, the soft start and the hard start and the practical, right. And this video I'm just going to show you a brief introduction of the AMD platform, the single bridge or single FCH, right, with the AMD APU inside and integrated graphics inside, right, or we can call it the independent graphics card. All right, so as you can see here, we have this block diagram of a Lenovo Y485, right, common laptop, compile based motherboard, as you can see, and I'm going to explain each of these sections on the block diagram, right, so you can get a brief understanding on how to read a block diagram effectively, right, and understand the basic structure or the architecture of the notebook motherboard when it comes to the AMD platform. I'll do one for the Intel in another video. Alright, so this is the AMD platform, which is the FS1, the R2, right, APU, which is a socketed CPU, you see, UPGA 722 pin with 35 by 35 millimeter in size, and this is a socketed CPU in a socket, not on the BGA, right. The BGA one, you would see something like UFC BGA, right. This is the BGA, this is the Hudson, which is the FCH, which is the Fusion Controller Hub. Alright, this is the Fusion Controller Hub, which is similar to the PCH, but this is AMD, so it's called the Fusion Controller Hub. Now, as you can see on the left of this block diagram from the CPU, we have DP, which stands for display port, right. So we have 0, display port 2, display port 1, so it's a total of 3 output display interfaces. Alright, so there's 3 display modules that inside of the CPU. Alright, and the first one, which is display port 0, which is the LVDS, and it is going to a translator. This is a conversion chip. It converts or reformat the LVDS signal and sends it to the LVDS connection. Alright, and this is the translator RT, which is Realtek D2132S, right, and this is the translator which converts that LVDS signal that's generated from the CPU, right, and then it's passed to the display port, alright, and then to the LVDS, to this translator, and then to the LVDS connector. Now we have a display port 2, which is going to the HDMI connection. It is high frequency transmission of signal, very high definition media interface connection, and I'll explain all of this in my future classes. I've explained some, but I haven't finished completed yet, and this one I'll explain in a future class about everything you need to know about HDMI, right, and how LVDS work, everything about LVDS, red, green, blue. If one signal is missing, what's the output voltage, how white screen fault appear, come along, that is generated, and so forth, right. So this is the HDMI connection, and it is coming from DP port 2, which is a display interface, which is coming to the HDMI connection, high speed transmission frequency. Now the third one, which is DP1, which is going to the PCH. Okay, it is going to the PCH. Let me just open my pointer tool here. Alright, I use it when I'm teaching point to fix. Okay, alright, so as you can see, this is the display port 1. This is the third, which is the first one, the third, sorry, should be 0. Well, yes, it's okay. So as you can see here, this CPU doesn't support digital to analog, because it's the AMD doesn't support any form of analog to digital conversion. So what happens is that this APU sends this display information to the FCH, as you can see, right, and then the FCH will output it through this interface here to come to the CRT connection, because as you can see, VGA, digital to analog conversion, right? So the CPU doesn't support digital to analog or analog to digital to analog conversion. So what will happen is that it have to take this information and send it to the FCH. The FCH will now convert it from digital to analog, or from analog. This is only analog. Remember, this is an analog output, right? So the CPU is unable to do that, so the CPU passes its adjusting instructions through the registers, internal registers inside of the FCH, right? And ID verification signals it's passed through, and then the FCH will convert it from digital back to analog signals and then display output on your CRT monitors. So this is how this conversion is work, because the AMD platform CPU does not support the digital to analog conversion, so it is done through the FCH, right? So that's how it's done. So that's it for the display output interface for the AMD CPUs, right? All the integrated independent graphics is done inside of the CPU, except for one thing: it cannot convert from digital to analog. So it allows the FCH to pass its adjusting instruction to the FCH, and the FCH will do its job to convert it from digital to analog, which is a digital to analog conversion, and then it through to the CRT, all right, to your monitor. All right, the next on the right side of this CPU, we have the memory bus DDR3, which is a total of 204 pins, as we all know. All right, and it uses a 1.5 volt 1600 transmission of bus frequency, right? So this is the bus frequency, DDR3 1600 megahertz, right? And this is the transmission of frequency to and from the memory to the CPU memory controller inside. So the CPU memory controller inside of the CPU needs 1.5 volt supply, right? This one, but this board is a UMA, so it doesn't have an external graphics card installed, right? All the graphics is done display is done through the CPU, right? It also supports the PCI Express bus, as you can see, 2.0 for the card reader, your Wi-Fi, and your LAN, which is your LAN card. And this is your RJ45 connection, and that's done, and that's managed through a CPU. Before, normally it would be managed through your FCH or your PCH on the Intel platform for the PCI Express is concerned, but it's done through the CPU, as you can see. So all this PCI Express is done through the APU. All right. Over this side, the audio, which is a Azela, this is the sound bus. This is the connection communication between the sound card and the driver. This store is the driver, right? It is a Realtek audio output chip. So this chip is where you're going to install your drivers from for your laptop, for your notebook. And this chip outputs two output channel speaker. You have a microphone and audio jacks, one for headphone output and one for microphone input. So two output jacks, right? Some laptops nowadays have like one jack, which operates as a multifunction jack for both headphone and microphone. Okay. Below we have USB 3.0, USB 2.0 support for the camera. USB, your camera is connected through the USB, or Bluetooth is also connected to USB. Right, it supports support for the USB port 3.0, 2 on the left and USB 2.0 on the right. So it has a support for USB 3.0 and USB 2.0. Right, double LAN, which is the Wi-Fi LAN. Wi-Fi is connected to USB. All right. We also have USB support 3.0 with one USB charger for charging, right, which is fast charging. If you're charging your cell phones, also you can charge through this USB port one port USB dedicated for fast charging for your cell phones. All right, you have SATA, which is a 6 SATA serial connection, a total of 2, 4, 6 transmission, receiving. All right, 3.0, right, USB SATA 3.0 SSD, SATA 3.0 hard disk drive connection, and optical disk drive, right? So we have support for the native solid state drives. All right, below we have the LPC bus, which is the connection between the EC and the BIOS, the bridge, or the PCH or the FCH, right? So this is the common ENI KB9012, and this is the internal program. This has its own program. As you can see, the BIOS is not shared with the EC. The BIOS is connected directly to the FCH to read the BIOS, so it can initialize the soft start and to initialize all chips and to start the soft start. And below, the touchpad is controlling, or the EC is controlling our touchpad, or temperature controller sensor. It is a temperature control, and our keyboard, right? And as you can see, that's it for the PCI Express mini card. As you can see, it's connected through your PCI Express. See, PCI Express. All right, PCI Express SATA SSD, something similar to M.2. And here we have our main connection, which is UMI, which stands for Unified Media Interface, which is now for the AMD, which is something similar to the Direct Media Interface for the Intel, but for the AMD, this is UMI, which is Unified Media Interface. Alright, and this is the transformation of data signals to and from the FCH to the CPU. So if the hard drive want to access the CPU, it passes that address instruction to the UMI bus, or any other part of the any component want to request a specific signal, it must pass through the UMI bus, which is similar to the DMI, but for the AMD platform single bridge is called the UMI. Alright, so we're going to go to the adapter insertion page, where I'm going to explain about EMI, right, which is the electromagnetic interference, right, and I'm going to explain why they use these capacitors and coils in conjunction to generate and to protect the isolation and protection circuit. Alright, so this is the DC jack, JDC in 1, right? Pin number 4 and 3 supply, pin number 1 and 2 grounded. Right, so pin number 3 and 4 coming through this fuse to come to this coil. This is known as a filter coil, as you can see, and these are some decoupling capacitors here, which is connected to ground. Now the purpose of these coils and capacitors is to prevent electromagnetic interference, because you see, during the use of our notebook, we have other external output interference, which is a frequency which is given off by like our television or radios and cell phones and other devices, which gives us a specific frequency. Sometimes this frequency can be very annoying and can interfere with our circuit. So this is designed to prevent EMI from coming into our laptop to damage our laptop, to hit into protection isolation MOSFETs that are on our motherboard, and these components are able to prevent EMI. So the coil here, the purpose of the coil, right, so our coil is to pass low frequency, right, and blocks high frequency. Right, that's the purpose of the coil. Right, so our coil here, which is a filter coil, which is to pass low frequency and block high frequency, right, while our capacitors here do the opposite. Right, our capacitor does the opposite, so it blocks low frequency sorry, I mistyped, and pass is high frequency discharge. Alright, so these capacitors blocks low frequency and passes high frequency to be discharged. Alright, so that's a function of these decoupling capacitors. Alright, so as I said before, because of the interference of the outer environment, when the voltage passes through this coil, right, these capacitors basically blocks any interference of low frequency and discharges it to ground. Right, it is connected to ground, this part is connected to ground, right, and these components are working together to prevent EMI. Right, EMI, electromagnetic interference, from coming into our laptop motherboard to damage our input MOSFETs, or to create another damage, to a spike or surge during the laptop when we're using our notebook. So the EMI, which is the electromagnetic interference, which allows these components to work to prevent EMI interference from coming in, right, which can cause the circuit to behave abnormal or to stop working, and you won't be able to use your laptop or your notebook. So this is the purpose of EMI. This is why many times our input isolation MOSFETs are damaged. Right, and I'll show you. This is the input isolation protection MOSFETs. It's down another page down right here. So V in, as you can see, is coming from our adapter. This is your first input MOSFET. This is a P channel MOSFET, which is your RB MOSFET, and this is your AC FET, right? This is your AC FET, and this is your RB FET. So if any EMI to come in to damage our laptop, it will hit the MOSFETs first, right? These MOSFETs will cut off, right? Sometimes two of them will, very rarely find two MOSFET burn, unless it's a very high thunder like lightning or thunder, which can burn these two MOSFET. But most times you'll hit your AC FET, and this FET will always damage, and then this FET will be okay. So this is your protection isolation, and these two MOSFETs are acting as a fuse to protect, right? To protect and to isolate. So with the isolation means that when in adapter mode, these two MOSFET are cut off, and it will discharge from the battery, right? From the battery. So this is your battery MOSFET. So when adapter in battery mode, this MOSFET will turn on. As you can see, VIN will pull low, and this MOSFET will pull low. This is a P channel MOSFET, so the voltage at the gate is less than the voltage at the source. This is 19 voltage coming in, the 18.6 voltage coming in to your input MOSFET, to your battery MOSFET. And when this voltage comes low, as you can see, then what will happen? PAC in signal will come in, and this will conduct. This is a N channel transistor. This will conduct. This will become a voltage divider. As you can see, it is clamped. This is clamped in. This diode is clamping here, so you'll get a fixed voltage here of about 6 volt, which is coming. So this resistor PR304 and PR306 is fixed with the help of this diode, right? And then you'll get exactly 6 volts coming in to discharge. So your battery can discharge, and this is coming from your battery mode. As you can see, this is a battery, and your battery will discharge, and these two MOSFET will be cut off or isolated. So this is protection and isolation. Okay, so EMI is what damaged most of your input MOSFET, electromagnetic interference. So you need to pay attention to these components. They are very important, which is coming from the DC jack, your adapter, right? So these devices, a fuse and a coil, filter fuse and a filter inductor, or a coil and capacitor, which is connected to ground to prevent electromagnetic interference to come in and damage your isolation protection MOSFETs. Alright, so I hope you learned something from this video, and I will put stay tuned for more videos, demo videos, right? If you want my full course, it will be available for purchase. Alright, it is more for I'll tell you the price in the future. Hopefully by next year, definitely I'll start and launch my online training, so you guys can get the real hang of how to repair a laptop motherboard and to maintain a laptop motherboard during your maintenance repair process. Okay, so this is the Chipmaster, and I hope you enjoyed this video. Thanks for watching.